Now this is a series based question. So we have x boxes b1, b2, b3 till px with a certain number of balls in each. Okay. Number of balls in the nth box is n more than that in n minus 1th box for n more than 1. If the number of balls in b1 is 7, so what is given to me is first case b1 has 7 balls. So b2 will have 2 balls more than b1, which is 9. b3 will have 3 boxes more than 9, which is 12. b4 will have 4 boxes more than 12, which is 16, and so on and so forth. And we have to find the total number of balls in x boxes put together. That means you need to find the summation of all this series. Okay, the series which will we have is s is equal to 7 plus 9 plus 12 plus and so on and so forth till tx, where tx is the number of balls in xth box. Now whenever you have this kind of series in which the differences of the consecutive terms are in AP 1, 2, 3, 4 and so on and forth, we'll use a specific method to solve this. We'll write this series again, s is equal to, but we will shift 1 terms to the right hand side. So 7 plus 9 plus and so on. Here will come x minus 1th term and x term will come here. Now if you subtract this, you will get 0 is equal to 7 plus 2 plus 3 plus and so on till tx minus 1 minus tx. This tx will come to the left hand side, gives you tx is equal to 7 plus 2 plus 3 plus and so on and so forth, and this is an arithmetic progression. Now we need to find the number of terms in this series. Okay, 2 plus 3 plus 4 and so on and so forth. So in the initial series there are x terms. Okay, and these are x terms, and we have shifted 1 term to the right side. So this series will have x plus 1 terms, out of which this is not taken and this is not taken. That means this series has x minus 1 terms. And you can clearly see that this series 2 plus 3 plus 4 is a summation of consecutive natural numbers. We know that the summation of first n natural number is n into n plus 1 upon 2. Here 1 is missing, so I can write this as 7 plus n into n plus 1 divided by 2 minus 1. N into n plus 1 upon 2 is the summation of n terms, but 1 is missing, so I have subtracted 1 from this. That means my tx will come out to be 6 plus n into n plus 1 divided by 2, or when we solve it, it will give you 1 by 2 n square plus n plus 12. This is my nth term. Okay, I need to find the summation of some terms. So whenever we have nth term in terms of n, okay, or x, whatever, okay, so for summation we need to find the sigma of these series. So if tx is this, summation of the terms will be sigma of 1 by 2 into x square plus x plus 12. This n is nothing but x. Now this will be nothing but 1 by 2 into sigma x square plus sigma x plus 12 times sigma 1, and we know that sigma x square is nothing but summation of squares of natural numbers, which is x upon 6 x plus 1 into 2x plus 1 plus sigma x is x into x plus 1 divided by 2 plus 12 times sigma 1 is nothing but x. When you solve this, you will get this as x upon 6 into x square plus 3x plus 38. So my answer is option A. Right. Now there is a shortcut here. It is given that first ball has n7 number of balls. So that means when you put x is equal to 1, s should come out to be 7. Similarly, when you put x is equal to 2, s will come out to be 7 plus 9, which is 16. Now just check the options, and whichever option satisfies this condition is my answer. So you can clearly see that only option A satisfies this condition. When you put x equal to 1, s equal to 7, and x equal to 2, s is equal to 16. That means we need not to do these much calculation. We need to just put the values of x and find the value of the summation of series. That's why the answer is A option again.